In this video, we're going to see how we can use arrays as inputs to functions. So, for example, let's suppose that I wanted to define a function that added two arrays, and I'm going to use this program to show how I can do that. So the tricky thing here is that arrays are actually pointers, and we'll learn about pointers later in the class, but what that means is that when we pass arrays into functions, we're really passing them by reference. And what we've seen so far when we've defined our own functions is that we pass by value. So when we pass in some variable or some value to a function, the value itself, say I had a variable x and it had the value 5, it was an integer and it had the value 5. When I pass that integer into a function, I'm actually just passing the value 5 in. That function can't change the memory that is associated, that is named x. That would be passing by reference. So I think really we'll understand this by seeing how it works in practice. So to start off, I have two integer arrays here, both have size 5, and in one I'm initializing my array to all subscripts have value 1. I'm using a syntax that we haven't seen yet that comes from our GCC compiler in particular, so not all C compilers will be able to do this, but as long as we're running our programs on the server, we're going to be able to do it just fine. So we're saying from index start, then we use a ... and then this is our ending index. We can set those all to the same number. So I said 1 here, but I could have said 10 or anything that I wanted. Here I'm just initializing my array using the curly braces like we've seen. And so if I want to add these two arrays, what I'm actually going to need to do, because I can't really return an array from my function, what I can do is I can declare an array for the sum. So I might say int r3 is also going to have size 5. And now when I actually go to call the function that I still need to define, it might look something like this. Use function to add r1 and r2, resulting in r3. And so I haven't defined this yet, but let's say my function has name add array, and its inputs are going to be r1, r2, and then I'm also going to need to input r3. And then finally, I'm also going to pass in the size of my array, because there's no function that I can really use to get that information. And so if I were to write this right now, then Vim would tell me, hey, you haven't defined this yet. So if I want to define my function below main, I'm going to need a function prototype up here. And so what that'll look like, so we're not returning anything, we're passing by reference, and we're just assigning R3's values inside the function, and those will just be assigned. We can access them later. So I just have, I keep wanting to call it print, but it's add array, and what this looks like is I have r1 is an int array, right? And I don't necessarily need to tell it how many elements it has. R2 is an integer array, r3 is an integer array, and then finally my last argument is an int. And now let's go ahead and define function. So again, it's not returning anything to me. And here I'm going to have my int array, and I need to give it a name now. So let's say I call it A. And so here my syntax is I have my brackets after the name to indicate that it's an array of ints. Let's say I call my next one B, my next one C, and then I also have this size of array, and I'm just going to call it N. And so inside my array, my add array function, all I'm going to do is just loop over the elements of A and B and store their sum in C. So I can use a for loop, as we saw in the last video. So I can just use a local variable here that I set to start at 0. I'm going to go until I is less than n, because I go to size -1. And I'm going to just increment by 1 each time. And then just implementing what I said in my comment there, I would just set C at I to be A at I plus B at I. And let's see if this works. So I guess let's actually think about what we expect. Maybe let's add a print statement. So if I ran it right now, I could check that, does it compile, but I want to check that it actually worked. So let's do something like for I and I. So I just want to print out each element. In order to do that, I need to use a loop. Yes, 5. My array has size 5 here. And so let's print. And what do I want to print? I want to print C. Oh, except it was called C inside my function, right? But it's R3 here. Maybe I'm just going to print R3 at I. And once that's done, I'm going to print a new line character. And I guess this will not give me any spaces, so I'll just put a space there. So let's compile that. Oh, I guess what I wanted to think about is what do we expect to see. So R1 is just an array of every position is 10, so I just have 5 10s. And R2 is 1, 2, 3, 4, 5, so I expect R3 to be 11, 12, 13, 14, 15. So let's go ahead and see if that's what we get. Array sum. We didn't get any warnings or any errors, so that's good. And we did get 11, 12, 13, 14, 15. Great. So that is an example of how you can create or manipulate an array inside a function by passing by reference. So even though I didn't return anything, I still made changes to this R3. So one other thing that I wanted to show you here is that in order to ensure that these first two arrays don't get changed inside the function, we can use the keyword const. And I think I'm going to need them down here as well. Let's take a look. And so what this is doing is this is telling the compiler that we will not change A inside this function. And so we do this to indicate that A and B are inputs. And because C doesn't have a const in front of it, we expect it to be an output. So A and B are const, so they are inputs. And then I would say C is not const, so we expect it to be an output. And let's just see if this compiles. And it does. So what does this const actually do? Well, say I tried to change A inside this function. So I just said, I'm going to sneakily set whatever A at 0 was to whatever it was plus 1. And what do I see? So this error maybe is a little hard to understand at this point, but it's saying that I can't change A because it's const. So it's saying it's read-only. This asterisk A is a pointer, which is the same as an array. And so even if I didn't have these errors in Vim telling me what's going on, I would see that error when I went to compile. And so if I took out, oops, I'm trying to look at my file. If these weren't const, if A wasn't const, let's just say, then I have a difference between my function declaration and my actual function definition, so I'd need to take out this const as well. And let me do that. I am doing kind of a weird thing here by trying to say A sub 0 is A sub 0 plus plus, but I don't need the plus plus does assignment as well, so what I would need to fix here is just, I'm just going to jump to line 36. Maybe I'll just do something like, say I wanted to add 5. So now, finally, this should be allowed, and maybe we can run it. So the point there is that I took out the const, and now the compiler is allowing me to change A inside my add array function. And so, but that is not logical behavior, right? My add array function should not change A, it should just change C. And so that's just good programming practice to make sure that our functions can only do what we intend them to do, and so that's why we use const here. The last thing I'm going to show in this video is the conditional operator, which is just a slick way to write an if-else statement with very little code. So let me get out of here, and I'm just going to make a new C file, and we're probably going to need standard IO, and we just have our main here. And let's say we just want this program to do something simple like for a given array, print not 3 for every index where the array is not 3, and print is 3 for any index that is a 3. So let's just say I had an example integer array A, and I can declare it, let's say it's going to be 1, 2, 3, 4, 5, 3, 10. And you see here, I can actually leave this size off if I want, if I'm initializing it like this. But here, then I need to remember that I have 1, 2, 3, 4, 5, 6, 7 elements. Maybe I'll just save that. So this is, I'll call it size. And so without my conditional operator, this is going to be an if-else statement, right? I'm going to need to loop over my array. I want to go up to less than size, and then go up by 1. And so I would say something like if A at this index is exactly equal to 3, then what did we say? We said print not 3, and otherwise, oh, excuse me, this should be not equal to, huh? Otherwise, I should print is 3. And so, okay, let's just make sure this runs. Always a good practice. And let's see, in my third and second to last positions, I had 3s. Third, second to last positions, I had 3s. Great. So that's how I do that with my if-else. But my conditional operator is going to let me do something a little slicker. So let me just comment this out. We'll say with conditional operator. So what our conditional operator does is I say expression1, question mark, expression2, colon, expression3. And so what this does is it just says if expression1, then expression2. Yes, I'm gonna just make this nicer. So if expression1, then expression2, else expression3. So I could do something like, here we've got my expression1 is AI is not equal to 3. And I could do something like, so if AI is not equal to 3, then I would like to print not 3. Otherwise, I would like to print is 3. So let's just make sure this runs. And we got the same thing, so that's good. So a lot of times we'll also use this to assign variables. So let's say I wanted to create another array. I'm going to call it B, and it's also the same size, so maybe I'll say int B, and it has size, and I would like to fill B with values computed from A as follows. If element of A was odd, multiply by 2, otherwise keep same. So let's just go ahead and change this for loop here. So we said, let's say I declare a variable, I'm going to call it int val to assign, and we want val to assign to be 2 times whatever a at I is if a is odd, and just a at I if a is even. So how would I do that? I'm going to say val to assign equals, and now this is where I'm going to put my conditional operator. So I've got, how do I tell if a at I is odd? So that's going to, I can use my remainder operator. So if I divide this by 2 and it's 1, then that means it's odd. And in that case, so this is my, if this thing is true, so if this is odd, then I want val to assign to be a at I times 2. Oh, this is supposed to be a question mark here. So this is where my colon goes. Otherwise, I'm just going to have a at I. So you see how that's a really slick way to encode that if else. And now I would need to actually assign it. So b at I equals val to assign. And so you can see I could actually just do that in one line, right? I don't necessarily need to make this val to assign variable. I could just do b at I is equal to that. Oops. And so now what would have been a long if else is just one line. And we could run this just to make sure that it works. But for the sake of time, I'll just stop the video here.